So with appropriate sampling settings selected, a given frequency, you'll start recording your data. Note that the two are at steady state at the moment. And then you will displace one of the carts by a distance. Just make sure to record it, but it doesn't matter what. And you'll note that the carts will both move in a specific pattern. That pattern is relevant to the initial displacement that you put the cart at. And as you can see, the data in time for each is being collected by the VI. And you'll let that steady down to a 0 amplitude again, right about there, and you'll stop the collection for that set. So the final transient trial case that you'll do is inducing mode 2 oscillation by moving the carts in the same amplitude opposite directions of one another. You can see that the carts are moving opposite with approximately the same amplitude, with the node being in the center of that spring, point where it's not moving. Looking at the time response data, you can see that the carts are moving in opposite directions from one another at approximately the same amplitude. Note that right now, this is just in a slightly different scale than the top one. And again, you'll let those die down to 0 and export the data using the export again. And for all three of these cases, you will use MATLAB to run the FFT analysis of your system and determine the relevant frequencies for each mode 1, mode 2, and for the randomly displaced case. For the second case, you'll induce mode 1 oscillation by moving the two masses in unison with each other, same direction, same amplitude. What you can observe is the two masses move with pretty much the same amplitude, the middle spring barely moving at all, and similar behavior can be observed in the position versus time plots of each. And again, you'll let these steady down to 0. Now for each of these trials, do make sure that you're exporting your data once you stop it. Again, using the file export data. Don't use the save button on the VI.